Hello guys, welcome back to my YouTube channel, Hanumanth Reddy tutorial of Max. Today I am going to discuss some irrational proofs. So, which is very important concept and very damn sure question will be in your final examination. No doubt, damn sure. So, today we are going to discuss about for this we need one of the important theorem. See this, if p divides a square, then p divides a. I want this theorem, but proof is not important. Proof is not required. It's not necessary, but that its application is very important. So in the previous video class, I discussed about what is the word divides or factor. Just once you go through the previous video class, just the previous video class, please. In Euclid division algorithm, I discussed about the word divides or factor. Divides is nothing but remainder zero. Means that there is one of the condition for these two. Means here p is a prime number where p is a prime number. P is a prime number. You have to take prime. P is a prime. So my condition is that take any prime number and take a perfect square number, like means 1 1 is 1, 2 2 is 4, 9, 16, 25, like that, 36. So let us say if means you know very well. If means if this condition should become true. If it is satisfied, if this condition is already satisfied, then I can say that p divides a. Means so take a prime number and a perfect square, it should be in which remainder should be 0. Take any prime number 2 or 3 or 5 or 7 and one more perfect pair, so that the remainder should be 0. If it is possible, if this condition is possible, if this condition is possible, then I can say directly to p divides a. Let me illustrate with examples. Let me illustrate with some example. But application is very important. It's very important application. Very important application. So let me take 2 is a prime number. Let us take 2 divides 4. Yes. As per that statement, can I take like this? Can I take like this? As per the statement. So what I told here, it should be a perfect square number. As I have taken perfect square. See, 2 divides 6. It is also correct because I will get a remainder 0. 2 divides 6. 2 is a prime number, but 6 is not a perfect pair. 2 divides 6. Yes. Obviously, 2 divides 6 because if you divide 6 with 2, you will get remainder 0. Yes, the statement is perfectly right as per the remainder 0. But as per this statement, I can't take 6 because it should be a perfect square. Here it should be, yes, 2 divides 6 is correct, but as per this theorem statement, as per the statement, don't take 2 divides 6, don't take 2 divides 8, don't take 2 divides 10 because they are not perfect square. So take 2 divides 4, take 2 divides 16, perfect squares I need. So see, for example, 2 divides 4, I can write like this. Yes, I can write 2 divides like 2 square. Yes, is it correct? Yes, sir. 2 divides 2 square. Yes, I have taken 4 as 2 square. If a 2 divides 2 square, that means it is looking like a p divides a square. It is a prime number. This is the prime number, and it is a. Let us take this is a. So as per the statement, 2 divides 2. So if it is possible, if this condition is possible, then I can write 2 divides 2. Yes, correct or not? Yes, obviously 2 divides 2, yes, we will get remainder 0. Suppose you take 3 divides 9. Can I take like this? Yes, 3 is the prime number, 9 is the perfect square. If 3 divides 9, I can write 9 as 3 square. 3 divides 3 square. So obviously it becomes 3 divides 3. Yes? Am I right or no? Yes, obviously 3 divides 3. It's perfectly true. So that means take any prime number and one more should be perfect square only. Sir, if I take 3 divides somewhat 12. Yes, 3 divides 12. Yes, perfectly correct because remainder is 0. When you divide 12 with 3, you will get remainder 0, quotient is 4. Obviously, but as per this statement, 12 is not a perfect square. So, according to this statement, take any prime number and one more number should be perfect square. If any number p divides a square is possible, then obviously we can say that P divides A. This is very, very important theorem I am writing. Let us denote theorem has the number P. We don't know any number. Let us take this theorem complete statement as theorem P. Okay, na? So it is very, very application is very important. Proof is not important. So I have illustrated with the help of example. You can take anything. 5 divides 25. Am I right or not? Yes, 5 divides obviously 25. Therefore, 5 divides 5. So now I am going to prove that show that root 2 is irrational. This way we have to prove that. Very, very important. You have to remember Euclid's division algorithm. For that I am going to prove. I take the help of this theorem and also Euclid's division algorithm. Please once again revise previous video class of Euclid division algorithm, HCF and LCM. I have explained the concept very clearly. I hope this is very, very clear for you. Theorem P. Theorem P. Now I am going to discuss irrational proof. What is that irrational proof? Show that root 2 is irrational. Root 2 is irrational. So after this I will wind up this class. I want you try to do root 3. So try to understand. I will explain very slowly and very deep. I will go with very in-depth knowledge. Okay. So show that root 2 is irrational. How to prove? We can prove it by two methods. One is direct to proof, other is indirect to proof. Direct to proof already it is available in 9th class. Now I am teaching about 10th class. That's why I am going to choose indirect to proof. That is nothing but method of contradiction. Method of contradiction. We have total two methods. We can prove this. We can show by using two methods. One is direct proof and other is indirect proof. Direct proof it is already available in 9th class first chapter. But now I am going for indirect proof, means method of contradiction. I will. What is this method of contradiction? Sir, I object. This is false. I object. So after objecting, you try to prove it is irrational. You try to prove. At some point, you will get some false condition. So let us go. Let us discuss very, 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 very clearly. Okay, na? So let me go now. Let us start. So let us assume that proof I am going to show. Proof. Listen very, very carefully. Very, very carefully. Listen very, very carefully. Let us assume that. Let us assume. Let us assume that root 2 is rational. Let us assume that root 2 is rational. So it's a very lengthiest method. So that's why I'm writing very clearly. So try to understand. Now, root 2 is that implies as per the rational number definition. As per the rational number definition, the number which is in the form of P by Q or A by B. You can write anything on your own. So that implies root 2 is equal to A by B. A by B. So I told condition for this too, where in the first introduction class I explained the condition for these two, A and B, where A comma B are integers, A comma B are integers, A comma B are integers, and B not equal to 0, and A comma B are co-primes. A comma B are co-primes. A comma B are co-primes. This is a very, 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 very important condition for this. So now to prove this, I will proceed with squaring on both sides. Now squaring on both sides. Squaring on both sides. Squaring on both sides. So that implies root 2 whole square. Root 2 whole square is equal to A by B whole square. So now root 2 whole square means square and root gets cancelled. 2 is equals to A square by B square. So that implies shift B square. Shift B square means transposing. 2 into B square is equal to A square. Now let me prove here only. I want it. So place will not be sufficient, right? So can I write as A square is equal to 2 into B square? Yes, can I write like this? Now observe this one, all of you very clearly observe this. From this statement I can say that now how it is looking like a dividend is equal to divisor into quotient and kanipistunda. Yes, it is looking like dividend equal to divisor into quotient. Along, yes, as it is along the dividend is equal, it's completely dividend. dividend equal to divisor into quotient. మరి రిమైండర్ లేదుగా, రిమైండర్ లేదంటే డెఫినెట్లీ రిమైండర్ ఈజ్ నాట్ visible. That's nothing but remainder is 0. I can't write plus remainder. If you can't able to write any number, you can write plus 0. So that implies clearly in this statement remainder is 0. If remainder is 0, I can say that divisor is a factor of dividend or divisor divides dividend. Same statement I have explained in the previous video class in Euclid division algorithm. Sir, if remainder is 0, divisor is a factor of dividend or divisor divides division. So that one I am writing from this statement. From this statement, it is in the form of it is in the form of it is in the form of dividend is equals to divisor into quotient. That's it. So I can't able to write the plus, so it is always plus 0. It's nothing but here is plus 0. That means remainder is 0. That is I'm writing here, that is remainder is 0. Yes, I got remainder 0. So that's why now divisor is a factor of dividend or divisor divides dividend. So as per your textbook there is a word divides. That's why I'm writing same. So now that implies as per this statement, what 2 is divisor, a square is dividend. That implies 2 divides a square, 2 divides a square. Since 2 is a prime number and I got as a square as per theorem P. So I can write 2 divides a. So from this statement, so I got this statement. అది నా సొంతంగా రాయాలి, అది ప్రూఫ్ చేస్తూ పోతే అలా వచ్చింది, కాబట్టి therefore by theorem P I can write 2 divides a, 2 divides a. So since what is the reason? By theorem P. Don't write like theorem P, you write that complete statement in your exam. Since by theorem P. So since by theorem P. Now after this, so again for the two quantities apply Euclid division algorithm. So apply division algorithm for quantities 2 and a. Now 2 becomes a divisor, a becomes a dividend. Now apply division algorithm for this 2. See, listen very carefully. Now I am applying division algorithm. On 2. So to understand I am writing, don't write the statements on here. So apply division algorithm, apply division algorithm, apply division algorithm, apply division algorithm to the above statement, to the above. Apply division algorithm. So 2 becomes this is divisor, this is divisor, this is a dividend. Remember capital D, dividend. Okay. So as per division algorithm, dividend equal to divisor into quotient plus remainder. Since the word is divides, remainder is 0. So that implies a is equal to divisor into quotient kada, డివైజర్ ఇంటూ కోషంట్ కదా, డివిజన్ అల్గరిథం అంటే ఫార్ములా అదే కదా. మరి అంటే కోషంట్ మరి ఎంతనో తెలియదు, కోషన్ 1 2 3 ఎంతనో కోషన్. బట్ మెయిన్ పర్పస్ ఆఫ్ డివిజన్ ఏంది? టు ఫైండ్ అవుట్ కోషంట్ అండ్ రిమైండర్. అంటే కోషంట్ ఎంతో కొంత వస్తుంది కదా కంపల్సరీ, అంటే ఎంతో కొంత కోషంట్ అయితే రాకుండా ఉండదు కదా. లెట్ us టేక్ దట్ కోషంట్ as m plus 0. Why sir? In the word divides, remainder is 0. Dividend equal to divisor into quotient plus remainder and the remainder is 0 in the word. No need to write. If you want you can write, no problem. Since by division algorithm, I wrote that statement. So since by division algorithm I wrote that statement where m belongs to z. Write down why you taken m, where m belongs to integer. m అనేది ఎంతో కొంత కోషంట్, 1 రావచ్చు, 2 రావచ్చు, 3 రావచ్చు, 4 రావచ్చు, ఏదైనా రావచ్చు. అందుకని చెప్పేసి ఆ కోషంట్ అక్కడ m అనేది ఏందనేది మనం క్లియర్ గా మెన్షన్ చేయాలి. సో దట్ ఇంప్లైస్ నౌ a becomes, that implies a is equal to 2m, m is 0. ఓకేనా? So I got a. So here 2 divides a square. Clear? Listen very carefully. 2 divides a and I got it. Now substitute a equal to 2m in a square equal to 2 into b square. Let us take this as condition number 1. Take this as condition number 1. Now substitute a value in condition number 1. Substitute a is equal to 2m in condition number 1. In equation number 1 we will call, in equation 1, condition number 1. Now that implies from condition number 1, that implies a square is equal to 2 into b square. Now substitute A. A means A is repeated 2 times. A is repeated 2 times. Nothing but 2m whole square. 2m whole square. 2m whole square, which is equal to 2 into b square. Now can you tell me 2m whole square means 2m repeated 2 times under multiplication means 2m into 2m. 2m into 2m. 2 2 ja 4 m into m square. So it's nothing but 4m square is equal to 2 into b square. Now shift to left side. Shift to left side. 4m square divided by 2 is equals to b square. 2 1 ja 2 2 ja 4. Any doubt? Is it clear? Now what I got it? What I got? Now 2m b square is equal to 2m square. Any doubt? Listen very carefully. Listen very carefully. That is nothing but it is in the form of b square is equal to 2 into m square, right? Now again see it is looking like dividend equal to divisor into quotient as it is. Dividend equal to divisor into quotient as it is. Yes, it is looking like a dividend. This is take this complete number as dividend. Dividend equal to divisor into quotient lagunda complete ga. Yes, it is in the form of dividend equal to divisor into quotient, but I can't see the remainder. Therefore, remainder is 0 in this statement. So it is in the form of it is in the form of it is in the form of dividend is equals to divisor into quotient. So that is remainder is 0. That is I can say that remainder is 0. So now can I write divisor divides dividend or uh, divisor is factor of dividend? Yes, therefore 2 divides 2 divides as per theorem 3 2 divides b square. Am I right or not? 2 divides b square. So that implies since remainder is 0 by division algorithm, I wrote 2 divides b square. Since dividend is a factor of, divisor is factor of dividend. So that implies by theorem P 2 divides b. Divides అన్న factor అన్న ఒకటేగా, divides అన్న factor అన్న ఒకటే. ఈ 2 divide b ఎలా వచ్చిందంటే since by theorem P by theorem P since by theorem P. So this is condition number 2. Let us observe some condition number A where is 2 divides A. Let us take this condition number let us take this condition number 2. Let us take this is condition number 3. So observe condition number 2. Here condition number 2 nana. Let us take this is condition number 2. Now observe carefully condition 2 and 3. Observe very carefully condition 2 and 3. Observe condition 2 and 3. We can say that from condition 2 I have 2 divides A, and from condition 3 I have let us write condition number 3. Condition number 3. So friendly, I will share this PDF. Don't worry, I will share this PDF in the description. Please go through the description. I have got the access, so you can access through this PDF in through description. So now remember from condition number 2 and the condition number 3 I can say that 2 divides both A and B. Am I right? Yes, from condition number 2 and the condition number 3. See, I am writing here. Listen. From condition number 2, from condition 2, from 2 and 3, from 2 and 3, we can say that, we can say that, we can say that 2 divides both A and B. 2 divides both A and B. That is nothing but what is the meaning of divide? Divide is also called, we can use the word factor. Factor means remainder 0. That is nothing but 2 is common factor of A and B. See, just now at the beginning I wrote A and B. What is the condition for A and B? A and B must be co-primes. Must be. But what is the meaning of co-primes? I explained in the introduction class in the first day of this class. In the first video, you can observe what is co-prime. Co-prime means the common factor must be only number 1. No other common factor should get. We should never get any other number other than 1. We should never get common factor. But I got common factor as 2. I got other than 1. If you get common factor 2, therefore they are not co-prime. Why I got it is common factor? That is nothing but 2 is common factor of both A and B, mean A and B are not co-primes according to that statement. So according to this statement, A and B are not co-primes. So it fails our condition. What I told, what I have taken the condition, it fails the condition. It fails our condition. Beginning you wrote A and B are co-primes. Now I got at the end of this process, at the end of, I got A and B are not co-primes. What is this? How? Sir, అలా ఎలా జరిగింది, అలా ఎందుకు జరిగింది? బికాస్ మనం తప్పు అజంప్షన్ చేసుకుని నువ్వు అబ్జెక్ట్ చేసావుగా, ఇది తప్పు, ఈ క్వశ్చన్ తప్పు అని అబ్జెక్ట్ చేసావుగా, కానీ ఆ క్వశ్చన్ కరెక్ట్ అని నేను ఒప్పుకోవాల్సి వస్తుంది, తప్పదు. ఎందుకు తెలుసా? ఫస్ట్ నువ్వు ఏ అండ్ బి కో-ప్రైమ్స్ అన్నావు, ఇక్కడేమో కామన్ ఫ్యాక్టర్ 2 వచ్చింది. 2 అసలు 1 రావాలి, కామన్ ఫ్యాక్టర్ 1 వస్తేనే అవి కో-ప్రైమ్స్ అవుతాయి. మరి 2 ఎందుకు వచ్చింది? నువ్వు తప్పు అనుకున్నావు కాబట్టి అలా వచ్చింది. సో వాట్ ఈస్ ద మీనింగ్ ఆఫ్ ఏ అండ్ బి? దట్ ఈస్ నథింగ్ బట్ దట్ ఇంప్లైస్ ఏ అండ్ బి ఆర్ నాట్ కో-ప్రైమ్స్. A and B are not co-primes, which is a contradiction to that co-prime. ఇది మనకి ఆ తీసుకున్న కండిషన్ కి ఆపోజిట్ గా వచ్చింది, దాన్నే కాంట్రాడిక్షన్ అంట. విచ్ ఈస్ కాంట్రాడిక్షన్, మనకు ఆపోజిట్ కండిషన్ వచ్చింది, విచ్ ఈస్ కాంట్రాడిక్షన్ టు దట్ ఆఫ్ contradiction, which is contradiction to that of A and B are co-primes. So I strongly obey with this statement. తప్పదు. నువ్వే ఏ అండ్ బి కో-ప్రైమ్స్ అన్నావు, మళ్ళా నువ్వే ఏ అండ్ బి నాట్ కో-ప్రైమ్స్ అంటున్నావు. హౌ ఈజ్ ఇట్ పాసిబుల్? అలా ఎందుకు అయిందో తెలుసా? మనం లెటర్ అజ్యూమ్ దట్ రూట్ 2 ఈజ్ రేషనల్ అన్నావు కదా స్టార్టింగ్ బిగినింగ్ లో, అది మనం తప్పుగా తీసుకున్నాం. అది తప్పు అంటే వాడు ఇచ్చిన క్వశ్చన్ కరెక్టే. సో ఐ కెన్ సే దట్, so my condition failed. My condition failed. So that's why I can say that our assumption is wrong. Our assumption root 2 is rational is wrong. Therefore, we can say that root 2 is always irrational. So now I can write as so our assumption is wrong. So our assumption is wrong. Therefore root 2 is irrational. Hence proved. In this way you have to prove this theorem very. ఇలాంటి క్వశ్చన్ 3 మార్క్ కి ప్రతి ఇయర్ అడిగారు సిబిఎస్ఈ క్వశ్చన్ పేపర్ లో. ఎస్ఎస్సి వాళ్ళకు కూడా ఈ కాన్సెప్ట్ క్లియర్ గా ఉంది, కానీ మార్క్స్ ఎగ్జామ్ లో ఎప్పుడు అడగలేదు క్వశ్చన్. బట్ కాన్సెప్ట్ ఈజ్ వెరీ ఇంపార్టెంట్. ఈ కాన్సెప్ట్ లో మీకు మెయిన్ గేమ్ అర్థమైంది, డివిజన్ అల్గోరిథం బాగా వాడుకున్నాను, థియరం పి బాగా వాడుకున్నాను. అలా వాడుకుంటే నీకు ఈ థియరం పర్ఫెక్ట్ గా అర్థమవుతుంది. సో అది కామన్ ఫ్యాక్టర్ అంటే అర్థమైందా? అసలు కో-ప్రైమ్స్ అంటేనే కామన్ ఫ్యాక్టర్ అనేది 1 రావాలి, 1 తప్ప వేరే ఏ నెంబర్ రావద్దు. అలా 2 వచ్చింది కాబట్టి నా కండిషన్. ఫస్ట్ ఏమో మనమే కో-ప్రైమ్స్ అన్నాం, తర్వాత ఏమో మళ్ళీ నాట్ కో-ప్రైమ్స్ అన్నాం, అంటే తప్పు మనం అజంప్షన్ చేసుకున్నాం. సో దేర్ఫోర్ రూట్ 2 ఈజ్ ఇర్రేషనల్, హెన్స్ ప్రూవ్. ఇలా మీరు రూట్ 3 కూడా ఇలాగే చేయాల్సి ఉంటుంది. మీకు బాగా డివిజన్ అల్గోరిథం ని బాగా అప్లై చేయండి, బాగా అబ్జర్వ్ చేయండి, బాగా వాడుకోండి. So with this I am winding up the class. Please, my dear students of CBSE of different schools, please, if you like my teaching the way I am teaching, please subscribe to my channel. Please promote my tutorial name Hanumanth Reddy tutorial of maths in Jilelguda and Baranpet to your friends, neighbors or something, and don't forget to subscribe my channel. So please promote to your juniors also. సో ఇది సిబిఎస్ లో వెరీ ఇంపార్టెంట్ క్వశ్చన్. బాగా 1కి 2 సార్లు షేర్ చేయండి, నేను దీన్ని పీడిఎఫ్ రూపంలో షేర్ చేస్తాను. సో థ్యాంక్ యూ గైస్, గాడ్ బ్లెస్ యూ ఆల్ ఆఫ్ యూ.